Good afternoon. This is our final presenter for this afternoon. I'm Dave Mahan. If you haven't been here for some of the earlier presentations, I'm the Chief Security Officer for CenturyLink, and we've had the pleasure of hosting a number of presenters throughout the afternoon. And right now, I would like to introduce David Cleland. David is with Groundwater and Environmental Services Incorporated. He is involved in environmental data management, and he has 10 years experience in geotechnical and environmental consulting with the focus on the exploration and production of natural gas. Currently, David is helping clients find the best way to manage their data, streamline reporting, and meet regulatory compliance. Welcome.
So when I was invited to this conference, I love the name of it, and I struggled hard to come up with an equally bad pun. So my subtitle is, Will the Real Slim Shady Please Stand Up? What GES does as an environmental consultant, we work with the larger exploration and production companies that are in the Marcellus and Utica Shale. That's the big natural gas boom that you've been hearing about, fracking, love the term. Predominantly, our services are based on the baseline program. This is where, prior to getting a drill on the well pad and putting their first hole in the ground, they need to establish what is the groundwater condition of the surrounding area. This is both for their own defense. If a homeowner in the surrounding area issues a complaint, they have some baseline data that presents, what was the groundwater situation, what was your well like prior to us even arriving on site, as well as post-drilling samples, what's happened since we've done our initial fracking. Okay, it's a highly contentious issue. You have homeowners who are looking to protect, their way of life. They've lived on this property for generations. They've used the same wells. They've never had to rely on city water, as well as our clients who are interested in protecting their assets. So for them, big data is whatever is unmanageable for them. We have clients who've collected 600 samples, maintaining it all in a spreadsheet, or in some cases, two people's handwritten notes, and they have no way of accessing this data in a usable format. So I'm a bit nascent to this idea of big data, other than the term that's getting thrown around. For me, big data is anything that my client has trouble dealing with and needs support in collating, organizing, and presenting to higher-ups in their own company as well as regulatory bodies. So we're going to step back, general overview of what this well pad and this baseline program looks like. A driller or an operator has identified a parcel that they want to put a well on. They need to identify every landowner parcel within a radius around that location. They need to identify every location of domestic water on those properties. They need to schedule a physical visit to the property, a collection of a sample. That sample has to be sent to a lab. That lab has to perform a whole suite of chemical analysis on that sample, return that data back to the operator, who then has to report it to a state regulatory body as well as the homeowner within a certain time frame of having that data released to them. And the entire process has to be tracked from the point where they say, we want to put a well here, to how many times did you try to contact the landowner? How many times did you go out and actually attempt a sample? What were the sample results? When did you get the sample results back from the lab? When did the landowner receive it? And then the landowner sells the property. Well, that sample still has to track with the physical location. The parcel's been subdivided, it's been sold, it's been inherited by a great nephew. All of that has to be monitored and maintained so that at the point where lawyers get involved, our clients can go back and reference the original data set. A large group of these operators came together and formed the Marcellus Shale Coalition. And as a point of fact, I speak only for myself and for my company. I do not speak for the Marcellus Shale Coalition. I don't even speak for any of my clients directly on this. This is a GES learning opportunity. But the Marcellus Shale Coalition came together and identified a data schema that would adopt and address the majority of their data concerns for this baseline sample collection program. Again, earlier Industrial Scientific mentioned this idea of collecting gas readings and unstructured data, and the idea was with this database schema, minimize that unstructured data as much as possible. Every independent operator has additional data requirements. There's a place for that in the schema, but it doesn't affect the overall idea of maintaining, again, where was the sample collected, when was it collected, who was it collected for, what were the results, and when did the landowner and the regulatory agency receive those results. My job with GES is to help these clients become familiar with the schema and begin to use it for decision making. So we walk them through migrating their historical data, those Excel spreadsheets, those pads of paper, the one field technician that went out there and just wrote in a yellow notebook every sample that he collected and the results and the sample ID. Get that information into the schema, and then identify what that specific client wants to get out of that data. Is it strictly they want to get it to the regulatory agency, check that box and move on? Or do they want to have it in hand so that when they get that call at 5 o'clock on Friday that says, hey, Farmer Smith is complaining that his well's producing methane and he's able to light his kitchen faucet, they have verifiable and legally defensible data in hand saying when we drilled that well 6 months ago, he already had methane detected in his well, or oh crap, we need to get a response team out there. We might have had a leak or some incident. So with the Marcellus Shale Coalition, with this schema, the promise was they would be able to present it to the regulatory body sort of streamlined. We submit it to the MSC. MSC handles getting the data over to the proper regulatory compliance. And we're still working through that issue. We're still identifying how best. Our clients do not want to leave themselves open to any liability that they can manage to avoid. And the regulatory body has no compunction to help them with the liability. Their loyalty lies to the public constituents who say, we want to know what our groundwater looked like before drilling occurred or immediately thereafter. The software package is called Equus, developed by a company called EarthSoft. It provides that schema and some general reporting components, but they leave it up to the individual users to design the specific reports, the specific charts and figures. They've given us tools with active reports, ArcGIS, CAD. They've built out interfaces to pass the data, but it's really up to the user to control how that information is passed to those third-party software packages. Some of our clients have asked us to act as sort of turnkey. I have teams that actually physically go out and collect the samples. The labs report the data directly back to us. We use our hosted solution with EarthSoft to manage and maintain the data, and it's a phone call from a client that says, I need a map that shows me every methane detection reading in a 30-mile radius of X and Y coordinates. Or a lot of these clients are really scared of the cloud. They want nobody to have any data about their activities other than within their own firewall. And so it becomes a remote administrative position where I'm running training sessions and teaching these clients what their data is in the schema, how it's available for them to pull out, how they can better answer the questions of their bosses. So once we've walked through that process of migration, once we've walked through that idea of defining what you want to get out of that data, I sort of get to become a advocate both on the part of my client to the regulatory bodies. Hey, we're meeting your requirements. We've collected these samples. Here's our records. Here's proof that you received your results on time. I'm also an advocate to our clients, again, on behalf of the public. What can we do with this data? Pennsylvania is uniquely set at this point to have a data set that's unparalleled in terms of groundwater quality. I personally know of one county in Pennsylvania that had 90% of its parcels sampled within approximately 18 months. That's unparalleled in governmental organizations like the US GES, who have groundwater monitoring locations spotted across the state. You know, what can we do with this data? Partnering with universities to look at this as a chance to observe seasonality as well as local variance in all sorts of parameters that are natural occurrences, as well as advocate to the operators that they have a responsibility now to these homeowners to let them understand this data set rather than just spitting it out as a table that's attached to the back of a report. Hey, we sampled your well 2 months ago. Good luck in interpreting. And a lot of the operators are anxious and willing to, as a PR, explain this information. We have cases where people did not know that their wells were impacted by heavy metals or VOCs because it's always tasted like this. The well's been operating. My water's not dirty. If I pick it up and look at in the glass, it's clear. And it gives us an opportunity to provide some feedback to them that they wouldn't have otherwise gotten without this opportunity that the natural gas exploration provided for them. So it's somewhat of a tightrope. Again, these companies are liability adverse. They don't want to share anything that could potentially open them up to lawsuits, but at the same time, they want to be a goodwill ambassador to these communities that they live and work in. These wells are providing unparalleled opportunities for jobs, for economic growth in this area. They are not the evil corporate entities that some of the naysayers would like to paint them as. They found an opportunity to develop a product, to bring it to market, and to make a profit, and they live here. They want to be able to drink their well water just as much as the people that they have wells drilled on. So it's a rather short presentation. That's the general gist of it. If I have any immediate questions. Yes, sir.
Maybe just to be a little bit difficult at the end of the day. When I think of big data, I think of a lot of automation of data. Listening to your presentation, yours sounds like just a lot of data with a lot of manual entry.
Yeah, it is. It's a manual process. What we are collecting is information that physically requires somebody to go to a location, collect a sample, ship that sample. That sample is physically processed by a lab. Now, on the automation side, with the data schema that we use, there is an automated process for submitting that data once it's been collected. But we still have people in the field with a tablet PC populating an electronic form that turns into electronic data deliverable that's submitted, processed for business rule and nomenclature adherence, and sent up. I mentioned earlier the idea of trying to keep that unstructured data to a minimum. With the EQUIS schema, they've adopted a whole series of reference tables that controls 98% of that field data entry. Every single field on the form that the technician fills out is being checked for something or being automatically generated in terms of key fields. That information is uploaded. It's checked both in the field as well as on upload for adherence to those business rules, and it's in the database at that point for our clients to reference. Same on the lab side. They have their own reference values. They have their own format that they have to adhere to get it into the database, and ideally at some point that information will flow directly to the regulatory bodies without any manual requirements. But at the end of the day, we cannot automate the process of collecting that sample. We can't automate the process of confirmation that a landowner has received that mailing. There's still going to be that ticket that has to be identified as being received and signed and returned. So, big data, again, in my world, is any information that my client says, I don't know how to track, organize, or use this information. So, for me, big data in these projects, we're talking approximately 14,000 samples collected in the past 2 years. Each of those samples has an associated 200 to 300 analytical results associated with it. Each parcel can have multiple pads that it's associated with. So our total data set is in the low 100,000s. There are additional adjacent parameters that we're collecting remotely, remote weather stations that are generating 2 to 3 million data points, but that information right now is not being effectively used. I'm warehousing it at this point, waiting for someone to come up with some use for that data. And at that point, I'm anxious to get into data mining and identifying some correlation between, the barometric temperature, wind speed, precipitation associated with samples collected in that same general vicinity, and drawing that correlation. That comes back to advocating to our clients, what can we do with this data set? It's unparalleled in terms of its coverage and its quality, because at every step you have at least 3 interested parties looking over for any issue with your your sample collection, your laboratory analysis, your regulatory compliance. Somebody is anxious to identify issues with the data at that point.
I think it's tremendously important what you're doing, and be commended what you've done, because I'm thinking of 20, 30 years of revenue for natural gas and what it does for jobs and business and growth. Yeah. So doing what you're doing up front, I think, is really important.
Yeah, and we're looking at an industry that, at least in this area, not even 10 years old. This has really been a learning opportunity personally, coming from the field side. I used to be the guy out in the field with the sampling equipment, putting water in bottles and taking pictures of it, to seeing the opportunities we have here to establish that baseline, establish groundwater quality now, and then look at it in 10 or 15 years. We just have to wait. The data's coming.
Thank you.
Yes, sir.
Do you find that the data you're collecting is more complete, like your data sets are just of higher quality because of this process that you've implemented to kind of automate the report you're putting out to the landowners?
So it is definitely more highly structured. It's still variable in terms of quality because, as I pointed out, we physically have somebody sitting out there in the field, manually filling out this form, even with the business rules in place where in the field they know if they skipped a required field, it turns bright red, or if they put in a value, they key in a value that's outside of the accepted. For instance, latitude, longitude of every one of these wells, if it's not recorded to 6 decimal places, it turns orange. If they accidentally drop the negative sign in front of the longitude values and are plotting their well out in the middle of the Atlantic, it shows up blue. So it's been very useful as a user interface to have those controls in place. You still have that unstructured data that every client seems to think is of utmost importance, finding the appropriate place to put that. And then when they want to ask the question, how many dogs did the guy have? Well, where did we file that information for your specific needs, and why is that important? There's been a lot of opportunities to see how information that I didn't find specifically useful, but it was just part of the form and a requirement that it be filled out, where that falls in the workflow and what decisions are made on that. We found out that we asked the homeowner, how deep is your well? Just casual conversation item that we recorded. Turns out that for a specific client, that information passed to their operations team, which passed to the driller, which resulted in how deep did they have to install steel casing around the well when they were drilling it. One homeowner said, I don't know, 300 feet. So wrote down 300 feet. 6 months later, we get a call from the driller saying, are you sure you have a well in this area at 300 feet? We're at 100 feet. I'm drilling through rock at $10 per foot to try to get this steel casing in the ground. We're looking at $200,000 of steel to go in the ground because one person said my well's 300 feet. So we've noted better quality in terms of a complete technical data set. We're still working on, quality review of that information itself. A follow-up question to the guy is, how do you know your well's 300 feet? That would have saved $200,000 6 months down the road.
So you think as you progress through this, the collecting the data and then asking these follow-on questions is saving these companies money to make the drilling process easier?
Undoubtedly so. As soon as that instance came out and became a learning opportunity, every time now, how deep is your well? How do you know? And that qualifies the information so that when the drilling team gets that information 6 months down the road, they know how reliable that information is. There's a qualitative component of the quantitative number.
Thank you.
Yeah.
So as you stated, your industry's really only about 10 years old. And to Jerome's point at the lunch keynote, he was kind of saying, hey, if I'd have collected all the data points I could have 10 years ago, I'd be, have millions and millions of dollars more to play with. So is it something where you could or have engaged somebody else to say, what other data points can we collect? Let's say we're collecting 300 about this parcel. Could we collect 1,000 different points? Are there more pieces of information that you could collect and expand upon? Therefore, knowing more 10 years from now than you would if you only kept it at your 300, which is kind of the baseline.
Yeah, so like I said, the weather station data, we have these remote weather stations that every 5 minutes is pulling 12 different parameters, sending the data up into the database, and it's just sitting there. It's nice because now I can throw out a number over 300,000 when I talk about data points, but it's not being used. Somebody has at least identified that, hey, this information will be useful in the future, and we're just sort of putting it to the side until we have an opportunity to really dig into it and do an analysis. I have a coworker who's a PhD candidate that he and I are right now working on proposals to both the MSC and specific clients to ask for their data sets, or at least allow us to use their data for his thesis. Again, the opportunity to look at Pennsylvania in terms of entire counties and their groundwater and quality as snapshots, there's so much information and so much learning that can come out of that, and so many theses.
Are there other data points that you could collect that you might not have thought about to this point where somebody coming in from the outside would be able to say, oh, what about this, this, and this? That you could add onto your form that might be, oh, these are additional data points we might not use now, but in the future, they'll become a lot more salient to what we're looking for.
Absolutely. I'm always open to suggestions. So I think that's it for my time. I'll be around if you want to ask any other questions. Thank you, guys.